So children, right, we'll work problem number 2. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour to a potential difference of 50 volts. So we are given, on the second solution, we are given 96 coulomb of charge. So Q equal to 96,000 coulomb, right? Okay, 96,000 coulomb. And the next, the time taken for the passage of this much charge is 1 hour. So if at all we calculate that, that would be equal to 60 times 60 second. That is 60 times 60 second. That is equal to 3,600 seconds. That is time. And the potential difference across that device, heating device, is 50 volts. Okay, right. So here I want you to notice one thing. So power. We know well power. We have to calculate energy. Power is V into I, right? Okay, that's good. Now, that's okay, right? That's okay. But what actually is the definition of power? So we need heat energy. So the total work done is converted to energy, heat energy here. So work done or energy converted to heat, that is equal to power into time. But we have just seen the power is V into I into T. Okay, right. So we can use all three, V into I into T, where I should be found and then later T should be multiplied. That it takes a time. So what I do is, I know well that I into T is equal to Q. So what I do is simply multiply V and Q. What is V? So it is 50 into Q. What is Q? 96,000 coulombs. Right. Okay, 96,000 coulombs. So this is 50 volts. Okay, now how much will that be? So when I calculated this, so okay, children, right? So 96,000 into 50, and that is equal to 48 followed by 5 zeros. So, okay, right? So what is that? Right, 48 followed by, so that is equal to 48 followed by 5 zeros. That means joules. So this will amount to become 4.8 times 10 power 6 joule. So this is the amount of heat energy produced. Right? Okay, so that's it. So children, right, we'll now work the third question. So let us follow this. So what is he asking us? He has given us the resistance of an electric iron, that is 20 ohm, and the current passing through it is 5 ampere, and the next the time for which we are passing current is 30 seconds. What is the amount of heat generated during this time? So okay, right, we'll work that. Now, okay, right, so what has he given us? So he has given us the resistance of the conductor equal to 20 ohm. Okay, the next the current that is going is 5 ampere, and the heat the time taken is 30 seconds. Right, okay, what is the energy? Now, okay, so we know energy, power, they are related. So what is power is work per time or energy per time. So energy is equal to power into time. So that is power is V into I into, that becomes T. So that is V. What is V, children? And again, I can write it as this. I can write it as IR into IT. Okay, so that will become I square RT. So that is better. This way, bringing out the relation is better than pondering in your mind and making a mess with the formula later. So the energy, the heat energy, is equal to I square RT. I, what is I there? 5 square into R. What is R? That's 20. Into what is T, children? So that is 30 seconds. So that becomes 25 into 20 into 30. So that is 500 times 30. That is 15 followed by that many joule. Okay. So that is the heat generator. So okay, right. So that is the answer. So children, right, let us work example 12.12, and here we have the electric bulb. Okay, right, an electric bulb is connected to voltage source of 220 volts. So V is equal to 220 volts. Okay, very good. And the current is uh, 0.5 ampere. So current is 0.5 ampere. Now, what is the power? So naturally, power. So we define a power. You know, well, that is V into I. So right, okay, V into I. V. What is V, children? So power is equal to V. What is V? What is V? That's 220 volts into what is I? 0.5. That becomes 220 into 5 by 10. That becomes 110 watt, capital W. So that is the power. So children, right, let us now work on the example 12.13. There we are. Electric refrigerator whose power is 400 watt and works 8 hours per day. And what is the cost of the energy? Cost of the energy cost to operate it for 30 days at 3 rupees per kilowatt hour. So what are the things? So the power is equal to 400 watt. And then next the usage time, number of hours of usage. So usage, so that is, you can say time, that is 8 hours 8 hours per day. So let me just take it as H here. For convenience sake, I'll tell you why. So there's a simple formula which can be used for this one, right? Okay. And now what is the cost of the energy for 30 days at rupees 3 per kilowatt hour? So right, okay. So what is the electrical energy cost? So we calculate the electrical energy. Right, okay, now, okay, electrical energy. So again, going back to basics, the energy per time. So what is that? Energy is equal to power into time. So power is 400 watt. And time is 8 hours, right? So that gives us in watt hours. So that if I divide by 1000, that if I divide that by 1000, say, all right, that will give us the value in kilowatt hours. So 0.4 kilowatt into 8 hours. So that'll become 4 8 32, 3.2 kilowatt hours, or you can say that is 3.2 units. So this is the electrical energy consumed. So electrical energy consumed. Now what is the cost for 30 days? Okay, right? So we'll see the cost for 30 days. Okay, energy for 1 day. Energy for 1 day is equal to 3.2 kilowatt hours. Okay, right? Kilowatt hours. kWh. Next one. For 30 days, it'll be 30 times 3.2 kilowatt hours. 3.2 kilowatt hours, okay? So that'll become 96 units, or 96 kilowatt hours. So right, kilowatt hours, right? Okay, kilowatt hours. And that's it. Now next one. Cost of the 1 unit of 1 kilowatt hour is equal to rupees 3. What's the cost? Total cost of how many kilowatt hours is that? 96 kilowatt hours is equal to 3 times 96, or 96 times 3. That's a better sense. Okay, 96 times 3 rupees. So that becomes 200 and 368, 27, 28. So that becomes rupees 288. So this is what we have to pay for using the energy. So children, right, we will be into the exercises by the first problem. A piece of wire of resistance R is cut into 5 equal parts. If there are 5 equal parts, what will be each part? So that will be equal to R by 5. And these parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then find the ratio of R to R dash. So the resistance of the conductor of the wire equal to R, and resistance of each piece of wire will be equal to R by 5. And okay, effective resistance, as they are connected in parallel, so it should be 1 by R dash, they as he has given, 1 by R by 5 plus 1 by R by 5 plus 1 by R by 5 plus 1 by R by 5. Okay, right? So that's 1 by R by 5. Right? Okay. So that will become 1 by R dash is equal to 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So that is 5 times 5 by R. That is 25 by R. That's 1 by R dash. So now just transpose this R over to that. It will become R by R dash. That is equal to 25. So that's we have R by R dash equal to 25. So that's the. Now we'll go to the question number 2, children. Right. Which of the following terms does not represent electric power? So we'll just see. Now power we know well is equal to V into I. So that is there. This formula is there. Right. And if we employ Ohm's law, so we have Ohm's law. No? So is that we can represent Ohm's law by a triangle. How is that? V, then next I and R. V equal to IR and I equal to V by R. So that is how. So when we change those things, then it will become V equal to, say, if I write IR into I, well, that will become I square R. So we have P equal to I square R, right? So that's another formula. Is that there? Yes, it's there. And next one, right? So we'll go ahead. P equal to V into I. And so instead of I can write V by R, right? So V into V by R, that is equal to V square by R, that is P. So V square by R, is that there? Yes. So the only odd one out is IR square, so that is the answer. So this is not the one which represents electric power, right? So children, here we are into the third problem. An electric bulb is rated 220 volts and 100 watts. When it is operated on 110 volts, then the power consumed will be. So, okay, right. So there is case 1 here, and there is another case 2. Right? Now, in case 1, so what is the potential difference? 220 volts on the power equal to 100 watt. So, right, okay, in both the case. Now, okay, what is the second case? Second case, potential difference of voltage is 110 volt, and is asking us what the power is, right? Now, observe carefully. We know well that power is V square by R. So in both the cases, there is something which is not changing, that is resistance is not changing. In both the cases, what's common? The common thing is the bulb's resistance is same. Resistance is constant here for both of them, right? Okay. So what I do is I'll now find out the resistance here and employ that resistance here in this formula. Right? How do I do it? So I know that power is equal to V square by R. So right, Okay, now I'll employ R equal to V square by P. So I work it here, children. And what is that? R equal to V square. What is V? 220. V square, he says. So 220 into 220 divided by P. What is P? 100. 100 watt. 1, that's gone. That will give us R equal to 484 ohm. Right. Now this 484 ohm we'll employ here. Right. And get the value of P. So P is equal to V square by R. Right. So just make some space for here. Right. Yes. Next one. Okay. P equal to V square by R. What is V there? 110 times 110 to V square divided by R. What is R? We have calculated 484. That is 121 followed by 2 zeros divided by 484. 121 once, and that becomes force. So that will be 100 divided by 4. That is equal to 25 watt. So that's 25 watt. Therefore, power is 25 watt. So children, right? So we have calculated the power of the second one, second way or second case. So children, right here we work with question number 4. And what does it say? And two connecting wires. There you are, two connecting wires of same material. Okay, material is same, the lengths are same, the diameters implying the areas are same, and they are connected first in series and then in parallel, and in a circuit across the same potential difference. So what's happening is when these conditions of material, length, areas are same, the resistance will be same. So there are two connecting wires of same resistance. That's one. And they are connected in series one time, and the other time they are connected in parallel. Right, okay. So now, so let the resistances of each wire be equal to R. Right, okay. So resistance when connected in series, Rs will be equal to R plus R, that is 2R. So we have Rs equal to 2R, right there. Now if the resistances are connected in parallel, right, then now we know well that Rp will be equal to R into R by R plus R. That will be equal to R square divided by 2R. That is Rp. So there we are. That will become equal to R by 2. So Rp equal to R by 2. Sorry, R by 2. Right? Good. Now what next? What next? So Rs, we have calculated, that is 2 times R. The next Rp, we have calculated, that is R by 2. Fine. Good. What next, children? So what else he asking? Heat produced in the case of series connection of that resistor, and the heat produced in the parallel connection. Right. Okay. So heat produced, what is the formula we have? So the source voltage is same. So V square, V is same. So V square by R into T, because this is power. So whenever, well, we know that heat produced, I write, so heat produced, H is nothing but the work done, the energy consumed, so that is converted into heat, power into time. So as V is same, for both connections. For both connections, heat produced H equal to P into T. So that will be V square by R into T. So, right, for H, S will be equal to V square by, what is R here? Rs into T, right? And that for HP equal to V square by Rp into T. That is right. Okay. So Hs equal to V square by, what is Rs? 2R. 2 times R into T. And HP equal to V square by R divided by 2 into T. So that will become 2 into V square by R into T. Right? So that's HP. So right, okay. That is HP. Okay. Now finding the ratio now. Finding the ratio HS by HP. So that is, what is the value of HS? V square by 2R into T. So V square by 2R into T. V square by 2R into T divided by 2V square by R into T. 2V square into T by R. Okay? That's good. Right. Now next one. So that will be equal to V square by this T, that T get cancelled. Okay. V square by 2R divided by, okay, divided by 2V square by R. So I'm doing it so that you understand it. V square by 2R into R by 2V square. R is gone, that's 1 times, that's 2 to 4. So 1 by 4. Therefore, HS by HP equal to 1 by 4. So what is it asking us? What is the question, actual question? So what is the ratio he asked? 1 by 4. So naturally it is 1:4. So therefore, so implies HS is to HP equal to 1:4. So there we are concluded that.